Okay, hello there folks. The next bit of our statistics topic is going to be standard deviation and the mean. Okay, now the mean we should already know about. That's when we add them all up and divide by how many there are. The standard deviation is like a kind of extra special range, okay? And there's going to be a few videos this week just because there's quite a lot to get through here. There's some new symbols we're going to introduce, and there's a few different things that I want to try and get covered with you. And as I've explained on Show My Homework, the textbook pages don't really explain this particularly well, and I think you probably need a better explanation from me. So we're going to go down this kind of video route a little bit more this week. So the first thing I'm actually going to get you to just think about is what the mean of this set of 5 numbers would be. Now we know that when we're working out the mean, we add up all the numbers. Now we're going to start to introduce some new symbols here. When we add up all the numbers, if we say that the numbers are given by x, then we've got this funky little kind of e thing. It's a Greek letter called sigma. Let me put it up on the right hand side here. And that just means add up all the numbers that we call in x here. And then we're going to divide by n, and n is the number of numbers. So n is the number of numbers, so I might just write that at the side. So n is the number of numbers. And this Greek letter sigma just means the sum of or add up. So sum of is a bit more mathematical, okay, a bit better literacy as well, but add up is maybe easier for us to understand. So when we're working out the mean, we add up all the numbers. So we're adding up 12, 15, 16, 18 and 24. Now at this stage, you don't need to show me the big long adding up sum. It's okay for you just to add them up yourself and write down the answer, okay? But you probably remember me saying previously, but if not, I'm going to remind you now, it's always best to do the adding up sum twice. When we're doing it in class, you can just check it with whoever's beside you, okay? But when you're doing it on your own in an exam or whatever, then it's better to do it twice. Now, if we add up all the numbers, we get 85, and we divide by the number of numbers. There are 5 numbers there, so 85 divided by 5 gives me an answer of 17. Now, you should always check, does that answer seem sensible? 17, the numbers here are in order. 17 would sit in there. That looks like a sensible answer. So the mean of this set of numbers is 17. Okay, now from there, we're going to work out something called the standard deviation. Okay, now the way I like to think about the standard deviation in terms of what it is if your mean was some number, let's call it x, and all the other numbers, if we put them on a number line, all the other numbers were quite close to the mean, okay, this would have a low standard deviation. It means the numbers don't really vary. They don't deviate very far from the mean. They're not very spread out. That's another way of putting it. They're very consistent, or they're not very variable. And those words we're going to come to in the next video when we look at comparing standard deviations. So just kind of bear that in mind, this idea of variance or consistency. If a standard deviation was higher, then your mean might be the same, or it might be different, but your data values, so the numbers that you're working with, might be much more spread out. Okay, so this would be a data set that would have a higher standard deviation. The numbers generally are further away, okay, from the mean. Okay, so it's more varied, or it's less consistent in terms of the data. So that's what the standard deviation that we're going to be working out is. It's a measure of consistency or of variability. Now the formula for standard deviation, in your exam paper, and when we start to look at Nat 5 exam papers very soon, you've maybe already had a look at them. Remember, we've pretty much done a third of the course already. There's 2 different formulas, but we are going to use this one. Okay, now the reason we're going to use this one is because I think this helps us understand a little bit better what's going on when we're working this out. Some people would argue the other one's slightly easier. I sometimes used to, and we're going to still look at questions where you would need to use the other formula at some stage, but we'll worry about that nearer the exam. This formula looks really complicated, and I understand that, okay? But I'm going to show you and talk you through a couple of examples, and hopefully you'll realise that if you can follow through the work that I'm going to show you, it's actually not too bad. We've already probably guessed that this S stands for the standard deviation, okay? If you go on and do statistics later on, You get different letters, kind of Greek letters for it, but we're just going to call it S at National 5. Here's the sigma, so the sum of, or adding up, x, which we did when we did the mean, but then it's take away something called x bar all squared. Now, x bar, okay, this x with a line on top is called x bar, and that is actually the mean. Okay, so x bar is the mean. Okay, and then n we knew about from working out the mean, that was the number of numbers, so we're going to do the number of numbers, take away 1. So the bit that maybe looks the most complicated here is this bit here. What's this idea of the sum of all the x's take away the x bars all squared? Well, don't worry too much about what that is. Once we're back face to face, we can talk about this a little bit more and you can ask me some questions, although you know you can ask me them on Show My Homework. I'm going to show you how we're going to do that. To work out this bit here in the yellow box, the sum of the x minus x bars, I'm always going to get you to do the following. We're going to make a wee table. And there's 3 columns to the table. The columns are x, which we've already talked about as being the different numbers. So in this example here, the numbers were 12, 15, 16, 18 and 24. So 12, 15, 16, 18 and 24. Now, the next thing that we're going to have, the next column, is going to be x minus x bar. So the number take away the mean, which is why we've already worked out the mean. And the final thing is going to be x minus x bar squared. So whatever answer we get squared. Okay, so this is what we're working with now. This is our little table then. Little reminder, I'll just write it at the side, that the mean that we worked out was 17. So we need that to help us get the standard deviation. So x minus x bar, well in this first case that's 12 minus 17, that's minus 5. Now you can just write the answer, you don't need to write the 12 minus 17 part, I'm just showing you where it comes from. Then we've got 15 take away 17, which is minus 2. We've got 16 take away 17, which is negative 1. 18 take away 17, which is obviously 1. And 24 take away 17, which is 7. This is I can't think about that, Sunday afternoon. Okay, now the last column is we take that number that we've just worked out in each case and we square it. So we've got negative 5. If we square that, remember we get positive 25. Remember, a negative number times a negative number is a positive number. So minus 5 squared is positive 25. Negative 2 squared will therefore be 4. Negative 1 squared will be 1. 1 squared will also be 1. And 7 squared will be 49. Now, if we go back to the formula, it asked us for the sigma, the sum of all the x minus x bar squareds. So this is the x minus x bar squared column, but it wanted the sum of, the sigma. So sigma is going to be what we get if we add all those up. Now, 25 add 4 is 29, 30, 31 add 49, and that's going to give us an answer of 80. So the sum of all the x minus x bar squareds is 80. So that's the number we're going to use. And n minus 1 is going to be, there's 5 numbers, but take away 1 is 4. So that's the other number we're going to use. Okay, so finally, to get our standard deviation, we're going to have the square root of the sum of the x minus x bar all squareds divided by n minus 1. So it's always good to write down the formula, remember. And then we've got the square root of 80 divided by 4. Okay, now I'm just going to go sideways for space here. 80 divided by 4 is obviously 20. So the square root of 20. Now we could write that as 4 root 5. Sorry, that's utter rubbish, not 4 root 5, it would be 2 root 5. Okay, so we could write it as a third in its simplest form. And you maybe would notice that I've not touched the calculator when I've done this question. Now that's unusual, but it can come up in paper 1. Okay, but actually, to be honest with you, if it's not in paper 1, it's going to be easier if you have it as a decimal. So here's a rare occasion where I'm quite happy for you to use a calculator and write it as a decimal, even although, okay, you can do it as a third. And here I would get 4.472 and so on. And it will usually tell you to round it to something specific. Let's do 2 decimal places here. So we've got 4.47. Now, you're probably thinking, Mrs. Kanak, is that a big number for standard deviation? Well, it kind of depends. Okay, so sometimes that might be, sometimes it might not be. It's the number that we're going to use, and when we watch the next couple of videos, you're going to see how we can compare them. So it's not necessarily that it's a big or small standard deviation, but it's how could we compare it with another set of numbers that's going to be important. Okay, so we're 10 minutes in already, and we've only done one example. Let me just rattle through it very quickly, and then I'm going to make a second video with a second example, okay, for you to watch, but you can have it a little bit split up. So, we're working out this week the standard deviation and the mean. We know how to work out the mean, but we've been introduced to some new notation. So we've got x bar means the mean, and sigma x means add up all the numbers, divided by the number of numbers, which is now called n. Okay, so we did that and we got 17. We're then asked to work out the standard deviation. Now, a low standard deviation would mean that the numbers don't really vary much from the mean, so they're all quite close to the mean. A higher standard deviation means that the numbers are more varied, so they're not as consistent. Okay, if you think about it in homework scores, if you had a high standard deviation with your homework scores, it maybe means that some weeks you get a score much higher than your mean, some weeks you get a score much lower than your mean. Your scores are kind of all over the place. Whereas if you had quite a low standard deviation to your homework scores, it means you're consistently getting roughly the same percentage every week, no matter what that percentage is. Okay, so it's not dependent on what size the mean is. We then have this formula, which we don't need to memorise. It's on our formula sheet, so there's a good thing, but we do need to understand how it works. The most complicated bit is this bit on the top part of the fraction, this x minus x bar all squared with the sigma in front of it. And to get that, we have to do this table, where we put in all the numbers, we then take away the mean from all the numbers, and then we square that answer and add it up at the end. Okay, once we've got that adding up, that sigma, that's your 80. Okay, in this case, we put that in here. Then it was n minus 1, so there was 5 numbers. Take that away, I get 4. And then we take the square root of 20, and this is one of the few equations. I don't mind if you write it as a decimal as long as it's not in paper 1. So I'm going to make a second video with another example, okay, and then I'm going to make a third video which talks about the wordy questions that I know you started to see doing box plots and interquartile range, but we're going to talk about that as well. So there's quite a lot to take on today.